Kia ora koutou. Welcome to this video on the structure and bonding of ionic compounds. Just a quick reminder, so this is all part of topic Chemistry 2.4, demonstrate understanding of bonding, structure, properties, and energy changes. So this video we're looking at the bonding and structure, so we're just looking at this part for ionic compounds. So there's a few different substances that we'll need to know the bonding and structure of, but in this one, um, in this video, it's just ionic compounds that we're looking at the structure and bonding of. And then in a future video, we'll look at the properties of ionic compounds. So, ionic compounds, structure and bonding. So we'll start by looking at the bonding part of ionic compounds. So what is an ionic compound? So first of all, ionic compounds, you have a cation, and this is almost always going to be a metal. Certainly for the purposes of this topic, you will get a metal, so the cation will be a metal. Other examples, for example, could be ammonium, which is NH4+, which doesn't have any metals in it. So that might be an exception, but apart from that, there's always the cation part of it. The positive ion is always going to be a metal. And an ionic compound is when you have that metal cation, which is bonded to an anion, which is always a non-metal. So a non-metal anion. So whenever we see that there's a formula, a chemical formula with a metal and a non-metal, we can safely say that that will be an ionic compound. So part of what we need to do for this topic is to be able to identify whether or not something will be an ionic compound. So we've got a metal cation and a non-metal anion. So these are held together. These two ions are held together by an ionic bond. So how do we know when we look at a formula? How do we know whether or not the atoms in the formula are metals or non-metals? So we'll go across. You might have this is the resource sheet you'll get in your exam. So remember this in this periodic table, you just have the symbols. You do not have the names. So as you're going through and revising or just studying, you need to remember the Li, lithium, beryllium, boron, and so on and so forth. So we need to be familiar with what the symbols mean. But so how do we work out, by looking at the periodic table, how do we work out whether or not something is a metal or a non-metal? So to do that, we need to draw a line in, and this line will not be given to you in the exam, so you need to remember where it is. Although things like tin and gallium, you're not going to get those in the exam. So pretty much anything aluminium and then further left, these are all anything on this side of the periodic table. And I'll just draw this down like that. So anything here is going to be a metal. All of these in this area of the periodic table are metals, and then that leaves us with the non-metals. So if we have a symbol that is, if we see a chemical formula that has a metal in it and a non-metal, we know that that will be an ionic compound. So we'll go over a very common exam question. So with this one, question 3, forgive me, I don't remember which exam it was. No, 2017. This is the 2017 exam. So it says complete the table below by stating the type of solid, the type of particle, and the type of bonding between the particles in each solid. So here we haven't done, so if we've got aluminium here, we've got the aluminium atom, that is just a metal, that's just a metal. So there is no metal and non-metal in that one. So that's not an ionic compound. We can look at sulfur. So here you've got 8 sulfur atoms bonded together. Sulfur, again, it's just one atom and it's a non-metal, so that is not going to be an ionic compound. Whereas the magnesium chloride here, we've got magnesium, which is on the left-hand side of the line. It is a metal, and then chloride is over here. We've got the non-metal. So this one must be an ionic compound. So when we complete the table here, the type of solid is that it's an ionic solid. The type of particle, excuse me, there we go. The type of particle is, so if we look back here, what are the particles that are in this ionic compound? We've got ions. So an ionic compound, the type of particle in an ionic compound is simply ions. And then for the final part of it, the attractive forces between particles is and we've done it over here. It's an ionic bond. So we get the ionic bond. That is all we need to do for the ionic compound. So already just in this short video, we can answer part of an exam question just by knowing that an ionic compound is made up of metal and non-metal ions. So just a note about this one. In the SciPad, you'll often see the attractive forces between particles in an ionic compound being written as electrostatic forces. It's not incorrect, but just from what I've seen with marking schedules, is that it always will say, and I would recommend being able to look at marking schedules when you're going through exams, but always in the exams it says that it's an ionic bond. Here we've got ionic compound, so maybe I'll just do a little tweak to what I've written here. So I've just said ionic, should really say ionic compound. Excuse me, ions, and then it's an ionic bond. So I wouldn't recommend saying electrostatic forces just because that's not what's written in the exam in the marking schedule. So if we go back here, so we've done the bonding. So this is the bonding, the ionic bond with a non-metal anion and a metal cation. We'll now just have a look at the structure of ionic compounds. So ionic compounds, they form a structure of positive and negative ions, which form a 3D lattice structure. So it's not just one and one like that. What ends up happening is that you get a cation which is bonded to multiple different anions, and then each anion is bonded to lots of different cations. So it'll look something like this. It's kind of like drawing a box. What I'm going to do though is not draw it out. I'll just copy this from the internet. But this is what it looks like. So you can see you've got the positive cations and negative anions. In this case, we're talking about sodium chloride, and they form a 3D lattice structure. So the structure part of it is important, that you need to be able to describe when you're talking about the properties of particular ionic compounds, or any ionic compound. For this standard, you don't have to differentiate between different ionic compounds. So that's it for this video. Next video we'll look at the properties of ionic compounds. Be sure to like and subscribe my channel for updates on when new videos come out. Exciting times. Thanks everyone.